Welcome to ClickMyProject.com. Our title is Risk Aware Query Replacement Approach for Secure Databases Performance Management. And this is our abstract. Large amount of data is and increased demand to extract, analyze and derive knowledge from a data are impairing nowadays performance of enterprises mission critical systems such as databases. For databases, the challenging problem is to manage complex and sometimes non-optimized queries executing on enormous data sets stored across several tables. This generally results in increased query response time and loss of employees' productivity. In this paper, we investigate the problem of enterprise computing resource availability. Our goal is to minimize performance degradation arising from resource-intensive queries. We proposed a risk-aware approach that decouples the process of analyzing resource requirements of SQL queries from their execution. We leverage XACML to control user requests and monitor database loads. This allows us to adjust available resources in a database system to computing resource needed of queries. A query can therefore run in a database if it does not severely impact the performance of the database. Otherwise, we propose to request a replacement query denoted what if query. Such query possesses results that are similar to the results of the requested query, thus is secure and provides acceptable answer when it executes without compromising the performance of the database. This is our data flow diagram, and we start a program. User enters a query. It's a SQL query. After that, enter the SQL query. Based on his query, extract that data set and it's sent to the policy enforcement point nearly to the RMM resource monitoring model. Then it's sent to that query to that global metadata catalog. It's stored in the database of code storing the data, storing the queries, and it's sent to TRM. That means the target rule evaluator, which is in the resource monitoring model. Target and rule evaluator, it sends to it's responsible for sending the queries to the policy information point and the policy admission point PAP and PIP, and it's processing it's information to that based on his user's query, and then after query is processed, then it is go to the performance prediction model. The performance prediction model is used to convert the query into the XML to the databases, and it's stored in the databases. It's and retrieve the data from the whole database. It's sent to the query adjustment model. Then after the query adjustment is processed, then it's sent to the prediction to the disk awares and sent to the query to process, sent to the retrieval of information to that policy information point. Then it's sent to that information to that user based on his entering into the query, entered the query. Now we go to see the demo. Going to see the demo. Run the home page of the system. The home page is running now. Click to start button. This user enters the query. Enter the education numbers. The search key is 9. Then enter start button. After enter start button, RMM is monitoring the XAML processes. The query is running now. The XML process is starting. After that, based on the queries, we having the XAML codings. And what if query analysis and extraction processes are also running, also displayed in the extraction of the database based on our user's query. Then click next. Enter PDP, that means the credential ID of persons. Enter 11. Search. His name is Prasad, HR, and catalog and product. Find ACL. Then the rule evaluator is successfully rendered, and find that the rule evaluator effect is permitted, and the condition is whatever the conditions, and algorithm first to be applicable algorithm is running now, and find ACM, and the ACM values are running in the window, and HR and the managers or the values are displayed in the file. Under the target fields are now we selected, the action is selected, the subject is name, role, option. Then resource, what is the resource we want to need? Product ID, catalog, and employee ID. Then click next button. It's a performance prediction model, PPM. Then choose workload from database. That's a SQL query. Now which is the queries? Then choose model.txt, it's a data set. Then the data set is selected. The selected data set is extraction in the window. We can see the display in the window. Then eradicate the resource requirement. Whatever the resource requirement is eradicate, which is displayed in the screen. Then get the database behavior, it's equivalent to the transformation. Now the transformation values are appeared in the screen. Then click next button to continue. Then first find the C1 and C2, C3, C4, C5 values. Before that, calculate the S1. After calculate the S1, find the C1 values. After find the C1 values, we can select S2. So calculate the S2 values. After S2 values calculated, then show the C2 values. After C2 values calculated, displayed, and select S2, S3 values calculated, and then display the C3 values. Based on the S4 values calculated, based on that we can see the C4 values calculations. Then S5 is calculated, then see the C5 values based on the S5. Then click next button to continue. Calculate the definition. There is a query similarity of QAM. In QAM, so query similarities. Then this calculates. Let's give the 20 based on the results are displayed in the screen. Here we can give 30 based on that query. We can display the windows in the screen. Display results are from the database. Then click next button. Find the term frequency TF. The frequency appears in the screen. The total number of files is 5. Then ds.txt, total number of files. Then find inverse document frequency file, frequency values. Then the inverse document frequency values is based on the time frequency. After that we find out the time frequency. We can compute the IDF inverse document frequency. Both get we calculate. Then we find out that TF and product of time frequency and inverse document frequency. Now we calculate that both time frequency and inverse document frequency. Then Give next. Compute the cost estimation of the if this model is representation of system resource availability. Enter cost estimation. Compute the cost estimation. The calculation is successfully. Then find out the display results are displayed on the screen. Then compute the similarities of the screen of the queries. Similarities of the queries which is from the user query and the modification queries. What are the waiting times? Find out the waiting times to retrieve the information and give the query into the system. Then the graphical representation of that risk aware performance database performance in what are the risk aware. We can see the risk aware graph. The users are in this side, and the queries are in this x-axis, and the user are in the y-axis. They find out the what are the fluctuation in which is appeared in the database manipulation, which is in the risk aware. Then choose the risk band. What are the risk band which is appears in the evaluation of similarity measurements. In y-axis the threshold values are appears in the screen, and the y-axis computational cost are appears in the screen. So what are the fluctuations which is appear in the graphical systems. Then click to similarity score. So similarity score appears in the screen. The cost of the cost is in the x-axis, and the similarities is in the y-axis. Then in the following the graph that appears in the screen. Then find out RMCE. Then query replacement processes. Then find out the whole experiment values. Thanks to listen.